right, hey guys. I am not there in person today, but hopefully this video helps you get through your notes today. So in the last class, we talked through the method of substitution to solve a system of equations. I know that some of you are probably still struggling with this and having a hard time, but please remember we will go over some questions in the next class. We'll have some time to review and look at all the methods we've done so far. But help each other out if you've got questions. There's other resources out there online. If you look up like videos on YouTube of solving equation or systems of equations by substitution, you can find some other methods and kind of things to show you what to do there. But keep trying to practice those, okay? Okay, so that was your homework. Remember, we're only going to have you try number 1 through 8. I don't know why that's not coming up right now, but you guys have that. Today, you've got notes number 4, and we're going to look at the other method to solve a system of equations. This is also an algebraic method, and this one's called elimination. This is the one I said that most of my students end up liking better than substitution, but eventually you can kind of choose which one you like better. And we'll do this more in Algebra 2 as well. Okay, so here's all your steps over here, right? And we'll kind of go through them one at a time. But this one's just quite a bit different than substitution. So try to kind of watch me go through the first couple. You'll start to get the hang of it as we go through it, and I'll kind of get you started on some of the homework problems as well. Okay, so with elimination, what we're going to do is we're going to take the two equations and we're going to add them together. But when we add them together, we want one of the variables to be eliminated so we can solve for the other one. Okay. Sometimes we can do this really quickly. Other times it takes a little bit more work. So I'll kind of show you a few different examples of how that works. Okay, so step number 1 here is we want to get the two equations in standard form, or at least in the same form, and we want to line everything up so that they all look the same. So if I look at example 1 here, I've got this first one is 5x minus y. Here's my equal sign, 12. And you see how the other equation, 3x plus y equal sign 4. So my x variables are lined up, my y variables are lined up, my equal signs are lined up, and then my constants are lined up. Okay, so you want your setup to look so they are in the same form and they're lined up like that. Okay, once that is set, this step number 2 is kind of the key to elimination. If necessary, we're going to transform one or both of the equations by using multiplication so that one pair of the variable terms are opposites. Okay, so what that means is I'm going to look at this 5x and 3x, and I'm going to look at the y and y here. Okay, now one of these pairs, I want the coefficients, the number in front of the variable, to be opposites. So if I look at my 5x and 3x, I need the 5 and the 3 to be the same number. Here they're not. So that's not set up the way I want it. So I'm not going to use that for now. Okay, if I look at y and negative y, well, remember we can always put a 1 in front of both of these. So that's 1y and 1y. One of them is negative and one is positive. That's what I want to have. If I have that set up, then I'm ready for my next step. So I don't have to transform this one. It's already ready to go, but we will have to later, okay? But that's what we want to see. We want to see one of my variable terms have the same number in front of the variable, but one of them positive, one of them negative. Okay, so then step number 3 says we're going to add the similar terms of the two equations, okay? So all I'm going to do is I'm going to take my system of equations here and I'm going to set it up like an addition problem. So I'm going to put a bar underneath it and a plus sign over here, and then I'm going to add all of my terms. So if I do 5x plus 3x, we get 8x. When I do negative y plus positive y, well, negative 1 and positive 1, that's just 0, right? Those two things cancel out. There's no y term left over. I keep my equal sign where it was, and then I'm going to do 12 plus 4, and I get 16. So you see how this variable here, the y's, have been eliminated by adding them together. Okay? Step number 4 then is we're going to solve the resulting equation. So what we have left here is 8x equals 16. So to solve that, I'm going to divide both sides by 8. So then we get x equals 16 divided by 8 is 2. So I've got one of my solutions, right? Now, whatever I get for my first variable, though, remember, we need an x value and a y value when we're solving a system. So now I'm going to take that x equals 2, and I'm going to plug it back in to one of my 2 original equations. It doesn't matter which one you use. You can pick whichever one you want. I tend to pick the one with smaller numbers because I think it's a little bit easier, but it's totally up to you. So I'm going to pick this second one here. So I'm going to take my 3x plus 1y equals 4. And then I'm going to take this x equals 2, and I'm going to plug it in for x. So that'd be 3 times 2 plus y equals 4. If I do 3 times 2, I get 6 plus y equals 4. And then to solve for y, I need to get rid of this 6. Since it's 6 plus y, I'm going to subtract it to get it over to the other side. Goes away there, and we're left with y equals 4 minus 6, which is negative 2. Okay, so now I've got my x and my y value. I can write that as my ordered pair that is my solution. So 2 comma negative 2. And there's the ordered pair that, again, remember, is the point where those 2 lines would intersect if we graphed them. Okay, and remember, you can always take those, plug them back in. They should work for both equations if you want to check your solution. Okay, now that one, again, remember, it was already set up to where I had those y variables where they would just cancel out, right? Sometimes that happens. It's nice. Sometimes it's not all set up like that for us. So instead, we might have something like this. Okay, now again, same first step, I want to make sure they're all set up. My C's are lined up, the D is lined up, the equals, and the numbers. So we've got everything lined up the way we want it. And now I'm going to check my variables to see if one of them matches up, right? So when I look at the C variable here, well, I notice, hey, they're both 6s, but they're both positive. Remember, I need one negative, one positive. And then if I look here at D, I have one positive, one negative, but 2 totally different numbers, 7 and 2. So usually what's easier is if you pick the one that already has the same 2 numbers. So our C's here both have a 6. The only problem is one of them, or they're both positive right now. I need one of those to have a negative 6C. So what I'm going to do is I'm going to take one of the equations. It doesn't matter which one. So I'm going to do the one on the top. And I'm going to multiply that whole equation by negative 1. Okay, so when I do that, I'm transforming this equation. Come on, OneNote. We're stuck here. There it goes. Okay, let's try one more time. Okay, so that would give us negative 1 times all of those things. So I'm going to get negative 6C. And then I would get minus 7D when I multiply by negative 1. And that would equal, sorry, I'm just distributing this negative 1. Negative 1 times negative 15 would make that positive 15. Okay, and then the other equation, I'm just going to leave exactly how it was. So it's still 6C minus 2D equals 12. But now, do you see how we've got one positive 6 and one negative 6? That's what we want, right? Because now when I go to do my next step, oops, I'm going to draw my line underneath here, and I'm going to add these 2 equations together. And that negative 6C and positive 6C cross out and make 0. And then I do negative 7D and negative 2D. That's going to make a negative 9D. And then 15 plus 12 gives us 27. So again, that's what we want to happen, right? We want one of those variables to eliminate. And now I can solve this for D. So I'm going to divide both sides by negative 9. And we get D equals 27 divided by negative 9, which is negative 3. So there's our first part of our ordered pair. By the way, it still works with different variables, not just x and y, right? But now I want to take that and I'm going to plug it back into one of my two equations. I'm going to pick this second one again. Again, it doesn't matter which one you pick. You can pick either one. So I'm going to take the 6c minus 2d equals 12. And I'm going to plug -3 in for a d. So 6c minus 2 times -3 equals 12. Gives us 6c. The -2 times a -3 makes a positive 6. And then I want to get c by itself here, so I'm going to subtract 6 on both sides. We get 6c equals 12 minus 6 is 6. And then if I divide both sides by 6, we get c equals 1. Right? So there are our two things. Now, if your letters are not x and y, people always ask me, like, how do I know how to make an ordered pair? They always go in alphabetical order. So if I've got C and D, that means C is like the x value, so it goes first. D is like our y value, so it goes second. So there's our ordered pair of our point. Again, that's the point where those two lines would intersect if we graphed them. Okay. So those are kind of the first two types of problems you're going to see. You're going to have some where they're already set up like this first one, and all we have to do is start adding. Sometimes we're going to have to fix the signs, right? Where we have to make it so one's positive, one's negative, and we got to multiply. Okay, let's then look at example 3. Okay. All right, so first thing I check, they're all lined up, right? X's, Y's, and the numbers. And then the next thing we want to look at are our coefficients in front. So here on my x's, I have a 4x and 3x, not the same number, and both positive. And then on our y's, we have a -5 and a positive 10. Okay, now I do notice a negative and a positive. That's good. I also know that if I look at 5 and 10, well, 10 is just twice 5, or 5 is half of 10, right? So those numbers are a little bit more related to each other than our 4 and our 3 on our x. Okay, so I'm going to focus on the fact that I've got a -5 and a positive 10 here. Because what I want to happen is I want to multiply one of my equations by something so that I end up getting the same number in front of that y. Well, can I multiply 5 by something to make it 10? Yes, right? If I take 5 times 2, then that will make it a 10. So what we're going to do is we're going to take the top equation here, and we're going to multiply it by 2. Okay, and I'm going to distribute to all three of these things. So 2 times 4x is going to give me 8x. 2 times -5y is going to give me -10y. And 2 times 23, after my equal sign, would give me 46. Okay, all three parts. Now, you see how I have a -10 here and a positive 10 here? That's what we want to happen, right? We want those two things to cancel out, so I don't have to do anything to the second equation. So I've got 3x plus 10y equals 31. And now I have this column here where I have a -10 and a positive 10, so they're going to cross out when I go to do my step of adding them together. So I do a plus here. 8x plus 3x is going to give me 11x. My -10y and positive 10y cancel out. And then 46 plus 31 gives me 77. So now I've got just one variable. I can solve for it. I'm going to divide both sides by 11. And that gives us x equals 7. Okay, and then same next step. I'm going to take that, plug it back into my other equation. So I'm going to take, let's do the first one this time. So I'll take that 4x minus 5y equals 23. And I'm going to plug in 7 for my x. So 4 times 7 minus 5y equals 23. Well, 4 times 7 is 28. Minus 5y equals 23. And then to get y by itself here, I need to get rid of the 28. So I'm going to subtract it from both sides. And then we get negative 5y equals 23 minus 28 gives me negative 5. I can divide both sides by negative 5, and I get y equals 1. Okay, so then that means we've got our x and y values, so we can make our ordered pair. X is 7 and y is 1. And there's our solution to our system. Okay, we're doing one step at a time here. That time we had to multiply one of our equations by an actual number, not just a negative or a positive, so that I could get those two numbers to match. Okay. Okay, let's do at least one more here. We might not do the last two, but we'll see. Okay, so our next one, again, they're all lined up, A's, B's, and our numbers. And then we're going to look at our sets here. So I've got 3A and 5A, and then I have positive 4B and positive 9B. Okay, so this time I'm going to think about, okay, what do I have to multiply to get those to be the same number? Okay, well, let's look at the 3 and the 5. Can I multiply 3 by something to make it 5? Well, not a whole number, right? And vice versa. I can't take 5 times something to get 3. So that doesn't work. Okay, well, let's look at the 4 and the 9. Can I take 4 times something to get 9? Well, if I do 4 times 2, I get 8. So not quite, right? So now we're in this position where I can't do like I did on this one, where I only had to multiply the 2 times the 5 to make it a 10. On this one, we're going to have to multiply both of the equations. It's kind of like getting a common denominator, right? So we can pick either one. We can do the A's or the B's. Most people tend to go with whichever one is first, so I'll go with that. So I'm going to look at 3A and 5A. Now, the easiest way to go about this is to just multiply one by the other. Otherwise, you can think about a common denominator and multiply by something to get that number, okay? But in this case, what I'm going to do is I'm going to take the top equation times 5, and I'm going to take the bottom equation times 3. And what that's going to do is here, when I do 5 times 3, I'm going to get 15. And here, when I do 3 times 5, I'm going to get 15. So it's going to make that first number both be 15. Now, remember, though, we want one of those to be positive and one of those to be negative. So actually, I don't want to multiply just by 5 and 3. I need to make one of those negative. It does not matter which one. So I'm going to do a negative 3. Okay, so now we go and distribute. So I'll do the 5 times all 3 of these. So 5 times 3A gives us, I'm going to write it down here, 15A. Oops, no, I'm not. It's being weird. Okay, so 15A. 5 times 4B gives us 20B. And then 5 times 2 is 10. B is kind of weird. Let's try that again. There we go. Okay. Okay, then on the bottom, I do negative 3 times all of these. So negative 3 times 5A is negative 15A. Negative 3 times 9B is negative 27B. And negative 3 times 1 is negative 3. Okay, so as long as we multiply the whole equation, this is still fine because they're still equivalent. But notice now, right there, I've got a positive 15 and a negative 15. So when I go to add these two together, my 15A and my negative 15A is 0. Those cancel out. That's what's eliminated, right? That's what we want to happen. And then I'll do the others, 20B and negative 27B. If I add those together, I get negative 7B. And then 10 plus negative 3, or just 10 minus 3, is 7. So then to solve, I divide both sides by -7, and we get b equals -1. Okay. And then just like before, I'm going to take that, plug it back into one of my original equations. It doesn't matter which one. I'm going to pick the first one again. So 3a plus 4b equals 2. I'm going to take b and I'm going to plug it in. So 3a plus 4 times -1 equals 2. And then that's, 4 times -1 would be a -4. I can add 4 to both sides. We get 3a equals 6. And then divide by 3. So we get a equals 2. Lots of practice on our solving skills here. So now I've got my a and my b. I can put those together to make an ordered pair. And I get 2, -1. Ta-da! Okay, so that's all the different types of things that you can see with elimination. And you're going to see all these in your homework too. Sometimes you're going to add only because it's already set up. Sometimes you've got to make the sign change so that they'll cross out. Sometimes you actually have to multiply one of the equations to get the same number. And sometimes you have to multiply both equations to get the same number. Okay. A couple other things can happen here. So if I look at this next one, now it's got a fraction in it, but remember we figured out how to get rid of that. We said we can just multiply everything by 3 here. And if I do that, I get 5x. We'll get plus 3y equals 21, right? I took 3 times all of those. Okay, now on my second one, notice I've got a 3y here, and this is just y. So if I took this second equation times -3, that'll give us the thing we want to eliminate, right? So that gives us -12x, and then -3y equals 3 times 14 is -42. Oops. Okay, and then that goes on to solve the same way we have. So I'm not going to finish that one off, but remember you can do the same thing to get rid of a fraction, just like we did on the one with substitution the other day. We've got one last one here. This one, the reason it's different, and we won't do a whole lot like this, but just so you know, notice I've got y and x and y, my equal signs and my numbers, like it's not lined up, right? So in this case, I'd have to rearrange this first equation to get those to match up. So I'm going to take that y equals 3x minus 7, and I'm going to rearrange. So I'm going to move the 3x over to this side. So I'd get -3x plus y equals -7. And now it looks like that one. So then underneath it, I can put 6x minus 2y equals 12. And now that all the different terms line up, right? So sometimes you have to kind of move things around to get those to match up. Now, if I finish this one, I want to take, let's see, I'm going to multiply this top one by 2, because that way I can get a positive 2y and a negative 2y. So I will get -6x plus 2y equals -14 when I distribute that 2 all the way through here. And then I still have 6x minus 2y equals 12. Now, hopefully you're noticing something on this one. Look at our x's and our y's. They're both going to eliminate this time, right? -6x and positive 6x, that's 0. 2x and, or that should be a y, sorry, whoops, it should be a y. 2y and -2y, that's also 0. So there's nothing left on the left side, it's just 0. Equals -14 and 12 would leave us with -2. So again, we end up in that situation where our variables all went away, but 0 does not equal -2. So if you get a situation like that, if it's false, then it's going to be no solution. Remember, if you end up where it's true, like you get 0 equals 0 or 10 equals 10, then that's your infinite solutions answer. Okay. So now we've kind of done an example of everything you could most likely see with these. I want to go to your homework, and I've got it in 2 parts here on OneNote. You're going to get it all as one packet and all your answers together, but I just want to show you kind of how these work. So you've got this first page. Oops, that's not what I wanted to do. Hold on here. Let's go back there. There we go. Okay, so this first one says elimination, and it's adding only. So if you look at all of these problems, notice like you've got your positive 10 and negative 10, positive 9, negative 9, positive 3, negative 3, right? They are already all set up. You don't have to do any multiplying. You're ready to just put that line underneath and add them together and solve. Okay, this whole first page is just like that. It's only adding. When you get to the back of that one, to the next page, notice up at the top it says multiply one equation. Okay, so for example, this first one, I see they're both 3's, but they're both negatives. So I'm going to have to multiply one of those by a -1, so I can end up with one positive and one negative, right? Same thing here. They're both 1x, but they're both positive. Sometimes it might be a number. So if I look at number 3, there's a -7 and a -14. Okay, well, I can make 7 into 14, so I only need to multiply the top equation by 2, and I need to do -2, so I'll get a positive 14 there. Okay, so these, on the second page, you only have to multiply one of the equations by something to get those numbers to match. Then on your third page of the homework, this is where we get to, you've got to multiply both equations by something. So 5 and 4 or 5 and 7, I can't easily make one of those the other, so I'm going to multiply both equations, right? Pay attention to your signs. And remember, you can do this where, okay, I'm going to take the top equation times 4 and the bottom equation times 5. And then I'm going to look at my signs. Well, this is positive, this is negative. So the signs are already the way I want them. I have one positive, one negative, so I just can multiply by the 4 and the 5. Okay, so that one is multiplying both equations by something like those last few that we did. Okay, on all of these, so there's 3 pages of homework there. I think, that last one has 8. I think on the first 2, there's 6 problems on each page, right? So again, let's just do half on each page. So on this one, let's do odds. Oops, write it on here. Same thing on our multiply 1, let's just do the odds. And then on that last page, same deal. We'll just do the odd problems. Okay, and that should be enough practice for now. On your last page, you've got answers to all 3 parts, so you can check them as you go. But try a couple of these at least. Again, I know with me not being there, it can be a little bit harder to figure these out, but try to kind of follow the examples on your notes. Each example on your notes, especially those first 4, are great to follow, right? Let's even do this. This is our adding only. Example 1 is your adding only example. Example 2 is multiply 1 equation, and this is just to change signs, right? That's all we got to do on that one. Example 3 is still multiply 1 equation. Oops. But this time we have to change a number, right? We had to get a number that was different. And then example 4, sorry, is where we had to multiply both equations. Okay, so those first 4 examples are just like what you're going to do on the homeworks. So kind of keep that in front of you as you're working on each problem, and that should help you remember what the steps are to solve there. Okay? All right, try your best. Like I said, in class on our next class period, which I don't remember if that's, I think that's not till next week on Monday. We'll have kind of some review and go over things and see if anybody's got questions. But try a couple of these on your own, see how you do. I'll see you guys on Monday.